All right, now guys, in this video we want to start talking about angle measurement other than measuring in degrees. We of course know that we use a protractor to measure angles, and we can measure our angles in degrees. As we see here, we saw the angles of a triangle, angles of any of our polygons, and we pretty much dealt with them in terms of degrees, sometimes fractional parts of a degree, but for the most part we talked about angles in degrees. Now, okay, we also gave you some kind of idea as to how you can use these angle measurements. So in other words, if you were to hold your hand at arm's length and spread your hand out as you see here, okay, the rays of light coming back to your eye would form an angle of about 20 degrees. If you were to hold your thumb straight up at arm's length, okay, then the angle formed, the rays of light coming back to your eye would form an angle of about 1 degree. We look at it this way, okay? So in other words, if you held your thumb up at arm's length, you could pretty much block out the sun or the moon. So in other words, what we'll say is that the rays of light coming back from either the sun or the moon are being blocked out by your thumb up in the sky. So we're going to say that the rays of light coming back form an angle meeting your eye at a 1 degree angle, more or less. Okay. Now, okay, we're going to talk about using measurements of small, like 1 degree, or even smaller than 1 degree. 1/60th of 1 degree, called a 1 minute. So we'll talk about that, but let's talk about where we might come across that. Typically, we know from our grade school geography rather, there is geometry in geography, because we talk about lines of latitude and longitude. So you can talk about, okay, your position on Earth in terms of degrees, latitude and longitude. Latitude measured, okay, north and south of the equator, measured in degrees. Longitude measured west and east from the prime meridian going through Greenwich, England, right here, okay? And so sometimes, okay, if you're going to talk 30 degrees on the surface of the Earth, you're talking a big portion of the Earth's circumference. So if you're going to talk smaller portions, then of course we're going to have to use smaller angles. Okay, so let's talk about how we look at that. Okay, so we know, in fact, our it was known some time ago from Eratosthenes he figured out, more or less doing the same thing, using these, measuring this angle, okay? But he figured that way back, okay, a couple centuries BC, as to what the Earth's radius was. We now know it to be approximately 4,000 miles. Oh, well, if we know the Earth's radius, then we know the circumference of the Earth is the radius times 2 times pi. So we figure out that the radius of the Earth is approximately 25,000 miles, okay? Now, we all know that the Earth is divided into time zones. And because we have what's called the International Date Line, where we go from one day to the next, we figure there are 24 time zones. So, if we have 24 time zones, and those 24 time zones are spaced fairly equally about the circumference of the Earth, we're going to say that if we take that circumference of the Earth, divided by the time zones, we got roughly 1,000 miles, 1,037 miles per, okay, time zone, okay? And we also say that since the full circle is spanning 360 degrees, and we're going through 24 time zones, we're going to say that the 360 degrees divided by 24 gives us 15 degrees of longitude between time zones, more or less, okay? So we're going to say that the time zones are roughly 1,000 miles apart along the surface of the Earth, but formed by an angle of 15 degrees, okay? So if we can do a little further subdivision, I'm sorry, this is not showing up, okay? The little further subdivision here shows that dividing the 1,037 miles by the 15 degrees gives us roughly 69 miles along the surface, the circumference of the Earth per degree of longitude, So that being the case, okay, we're going to equate that a little bit further, okay? So every 69 miles we travel along the surface of the Earth means that we are moving through a 1 degree angle. So in other words, if this distance along the surface of the Earth is roughly 69 miles, the angle formed by the rays extending from the center of the Earth would be approximately 1 degree. Well, we're going to split that 1 degree into 60 equal parts. And each one of those parts is going to be called 1 minute, okay? So one degree split into 60 equal parts, each one of those parts is 60 minutes, okay? Or 1 minute is 1/60th of a degree, okay? And from our previous calculations, okay, since 69 miles was formed by 1 degree, then 1/60th of that, or basically a little over 1 mile, would be the arc length that we get swept by 1/60th of a degree, or 1 minute of arc, okay? So if this angle in here is a 60th of a degree, or 1 minute of arc, okay, 1 minute, then the surface, along the surface of the Earth would be 1.15 miles, okay? That's commonly what we call a nautical mile. A nautical mile is that arc length along the surface of the Earth formed by an angle extending from the center of the Earth, sweeping through 1/60th of 1 degree, or 1 minute of arc. 1 minute of arc is commonly going to give us 1 nautical mile along the surface of the Earth. There's our Wikipedia definition, for 1 minute of arc. 1 minute of arc, okay, is the unit distance that is approximately 1 minute of arc measured along any median by international agreement is, okay, 6,076 feet, which should be pretty much that 5,280 times that value, okay? Now, let's get a little different perspective on this, okay? So if I had an angle, I can't even draw an angle of 1 minute, okay? I can't draw here an angle, so this is grossly exaggerated, but it's saying to you, okay, if the rays forming a 1 minute of arc, 1/60th of a degree, you would have to go 100 yards out before those rays are 1 inch apart. You would have to go 200 yards out before they are 2 inches apart, and so on and so forth. So, okay, so for the distance of the rays being 5 inches apart by an angle 1/60th of a degree, or 1 minute of a degree, 1 minute of angle, okay, we would have to travel out 500 yards, okay? So here's what's happened, okay? We know we have a circle. We can take the circle and we can divide it into degrees. We've agreed that there are 360 degrees, okay, in that circle. Now, so if we take 1 degree, okay, this is 1 degree, all right, which is, okay, is going to be equal to 60 minutes, okay? So this 1 degree, that's 1 degree with the single slash mark, is going to be equal to, okay, 60 minutes. So again, this is grossly exaggerated in terms of its size, okay? 1 degree is 60 minutes, or 60 minutes is equal to 1/60th of a degree. So 1 degree split into 60 equal parts. Each one of those equal parts is called a minute, an angle of 1 minute of arc, okay? So why can't we go further, okay? And in fact, we will need to go further and subdivide. So if we took each minute of arc and we divided that into 60 equal parts, as we do here, we get seconds. We get seconds of arc. Seconds of arc, okay? So that's even a second then is 1 1/60th of 1/60th of a degree, okay? So here you have it by definition. A unit of 1 second of arc is 1/60th of a minute, or 1/3060th of a degree. Here's an idea, again grossly exaggerated, because the rays forming an angle of 1 second of arc would have to be 4 kilometers 4 kilometers in distance before they were separated by a distance of basically an inch. Okay, so for the rays to be 1 inch apart, we'd have to travel 4 kilometers out on an angle that's formed by 1 second of arc. That is 1/60th of 1 minute, or 1/60th of 1/60th, or 1/3060th of a degree. Okay, here's another idea about that. Okay, here's the double indicators here are telling us we're dealing with a second. 1 second of arc. 1 second of arc. The rays forming an angle of 1 second of arc would have to span 45 kilometers before they were as far apart as that of a soccer ball. Okay, so the angle coming back of 1 second of arc, okay, from the soccer ball would have to be 45 kilometers away. Okay, so obviously that deals with some rather astronomical units, astronomical distances, if you can. In fact, we have something called the astronomical distance. That is what we call the distance between the Earth and the Sun. That is what we commonly call, what astronomers will call a astronomical unit. 92 million miles, 93 million miles roughly, okay? Now, okay, so here's the idea about what we call a parsec, okay? So if an angle of 1 second of arc, 1 second of arc, okay, were to have its rays separated by this 93 million miles, we would be traveling a distance of 1 parsec, which is, as you can see here, okay, 1.9 times 10 to the 13 miles, okay, times 10 to the 13 miles, okay? So that's a rather huge distance, huge distance. That's a very small angle, but when that angle the rays of that angle are separated by a distance of 93 million miles, we will have traveled effectively what we call 3.26 light years, which is 1 parsec. So that gives you some idea that although the angle of a second of arc is very small, okay, it's going to be used for very distant measurements, astronomical distance. Just as an angle of 1 minute of arc is going to be used on larger distances too, such as along the surface of the Earth, such as measuring what we call nautical miles. So there you have it, okay? And here's the summary, okay? Any degree is split into 60 equal parts called minutes, okay? So 1 minute is 1/60th of a degree, and every minute is split into 60 equal parts, okay, called seconds of arc, okay? So that 1 second of arc is 1/60th of a minute, or 1/3060th of a degree, okay? Very small angles, but when looking at them from very far distances, we can measure the distance between their rays, okay? So there you have it.